Anyway, a very warm welcome to this GSMA Intelligence Satellite and Non-Terrestrial Network Summit. I'm Alex Sinclair, I'm the CTO of the GSMA, and it's an absolute pleasure to have you with us here today. Now, I've personally seen quite a few iterations of satellite constellations over the years. I spent nearly a decade in satellite myself, but this time it feels a little bit different. And just to put that in context, let's start with the fact that SpaceX accounts for around 60% of satellites launched. They've sent over 5,000 birds into space since 2019, and they've actually got permission to put up a constellation of 42,000 in total. That shows how fast the industry's moved and how a few small innovators can really change the landscape. I should say, of course, they're only one of many companies that are trying to improve the economics of satellite connectivity. Whilst on the ground, of course, we still have around 600 million people globally that are not covered by mobile broadband. That's what we call the coverage gap. And you all know everyone benefits from connectivity. And that's something that satellite and non-terrestrial networks can easily provide. But it's not just for consumers. Enterprise, business, B2B, and indeed society as a whole benefits from coverage as well. Now, according to our own GSMA Intelligence, there's around $10 billion a year of annual incremental revenue that could be available to operators from B2B and enterprise customers and satellite partnerships by 2035. So the opportunity is there. Now, previous generations of satellites have tended to be proprietary. Now, with the advent of 5G integration and NTN, we're starting to see some real global standards for the first time, and that in turn should lead to more economies of scale. We're also starting to see the beginnings of commercial momentum with a growing number of partnerships between satellite operators and terrestrial carriers, and we're expecting to see scaled coverage coming online from 2024 onwards. But NTN isn't just about satellites, of course. We're also seeing a lot of interest in evolving drone regulations in different parts of the world. GSMA Intelligence benchmarked drone regulations and found the US to be a little bit behind in terms of supporting the drone economy, but that too is changing, including recent authorization for beyond visual line of sight operations with a special set of waivers. And of course, it'll evolve further as the value of the drone economy proves itself. If there's one thing that we at the GSMA understand, it's the importance of scale and economies of scale. And as drone and satellite deployments move forward, industry scale should drive not only new use cases, but also better economics as well. So I'm pretty excited that my GSMA Intelligence team has chosen to run this summit, with support, of course, from our sponsors, Comtech. I hope you enjoy the summit, use the opportunity to engage with others, but I also hope that you read the GSMA Intelligence research afterwards as well. So thank you very much.
Thanks very much, Alex. And welcome everybody to this session today into Las Vegas. We're really glad you could join us. As you can see by the attendance here, we know this is a really big topic in vogue. We hope we've put together a great program of speakers, and what we really want to do is help further the conversation. We know within the satellite dimension that there is closer integration with the telecom sector. We know that's accelerating, but we want to get more into detail about go-to-market strategy, partnerships, revenue, incremental revenue opportunities, and addressing some of the barriers that are still in place to access some of the consumer and business use cases. So my name's Tim Hatt. I am an analyst with GSMA Intelligence. I manage our research and consulting groups. We've written on this, as Alex alluded to, a fair amount, and we continue to follow the space closely. I'm going to kick off with a kind of short presentation, bringing in some of our analysis to set the table for some of the issues that we're going to talk about today. We then have two keynote speakers, Ken Peterman from Comtech, and then Paul Jacobs from Globalstar will be second up. And in between that, we're going to have a panel focused on sort of telco-satellite integration, and a second panel looking at kind of the deployment learnings and sort of lessons from the field about how we think about moving ahead. I know there's a lot of people, and you probably will have questions throughout. We won't have a chance to take all of them, but during the panels, what we'll try to do is give people an opportunity to ask questions, and we'll make sure that there is that chance, either with a mic or without. So we'll signal that opportunity when it comes about. This is a bit about us, GSMA Intelligence. We are the research and analyst arm of the GSMA. We have a full published research agenda, about 175 reports a year, a lot of data sets, including covering the satellite and NTN sector. And we are publishing a report this week on this topic as part of our radar series. So I'd encourage you to take a look at that when it's up on the site, probably tomorrow. And you can find out, hopefully a lot more sort of analysis in there that will hopefully be of interest to you. This is our speaker lineup, as I said, and we'll come to that as we get there. But let's go first as to sort of like, why does this actually matter? Why are you all here? Why is there so much interest in this? Satellite isn't new per se, but it is resurging with a lot of new innovation. Part of that is that there is still a big coverage gap. That's about 500 to 600 million people. And that is coming up on 7% of the world's population that live out of the range of a 3G or a 4G or a 5G network. Now that has closed over time, but the economics of reaching the final, what we call the final frontier, the last mile, are prohibitively expensive. And so trying to do that with terrestrial networks alone isn't going to work in the long term. And so there's this pragmatic reality kind of that partnerships between operators and satellite companies are really crucial to closing that gap. That's bringing people into mobility who didn't have a phone. It's also helping people who live in areas of some coverage, but it's sort of sporadic. So we know that's a big part of it. Second one, the options are there. I mean, the numbers are up. If you look at, we'll show a chart in a minute, there's an exponential rise in the constellation volumes orbiting the Earth. That has really come about as SpaceX, OneWeb, Kuiper, and others have put in place their constellation plans. Why does that matter? Well, it increases the capacity and the throughput availability from space. And it also increases the ground coverage. So the performance capability is up on what it used to be. Then there's a financial implication. When you talk about those 500 to 600 million people who don't have a phone and who are out of coverage, clearly that implies a revenue upside should they come online. I think a lesser appreciated but equally important part that we want to shed some light on is the enterprise side. 20 to 25% of businesses would use satellite connectivity. It's a big number. When you think about different sectors, utilities, some parts of logistics, manufacturing, they don't need necessarily 5G high-speed connectivity, but even low 3G speeds is better than what is currently available. So there is a sort of enterprise dimension to this that we want to discuss as well and see where that goes, as well as roaming. I talked about the numbers. I won't spend too much time on this, but if you look at this kind of chart here, and it's up on the screens there, so don't worry about squinting your eyes here if you can't see that. But what we're showing here is the pattern of sort of satellites in orbit over time. And the main thing to look at, there's different orbital patterns. You can be in low Earth orbit, you can be in middle Earth orbit, or of course geostationary. Now, geostationary has been the bulk of traditional satellite connectivity. That's servicing maritime applications and other things from 35,000 kilometers up in the sky at a fixed point. The low Earth orbit is really where we've seen the growth, and that's because the economics of launching those and operating those constellations has changed significantly. And so you see here on this chart, come from this SpaceX's original application and the number of companies that followed. If you look at the planned constellations that they have in the pipeline, that's a hockey stick heading out forward where you get to an exponential path. And that really is the capacity point that I was alluding to before. Another interesting thing, and we'll definitely talk about this in the panel, is the resurgence of what we call the direct-to-device. So I won't get too technical on this, but historically, satellite connectivity has required specialized receiving equipment. And you know about satellite phones, very expensive, difficult to procure. The change now is that by using direct-to-device, you can connect into people's handsets or IoT devices directly without the need for receiving equipment. That means it doesn't necessarily require a dish or a hop to reach somebody's end consumer device. And linked to that, NTN standards have been enshrined in the 3GPP 5G New Radio, which is a really big deal. You might not have realized this if you weren't paying attention a year ago, but that's a really big deal because it changes the addressable base of people that can tap into satellite manifold. And so that's a really big kind of key turning point behind our revenue projections, both in consumer and enterprise. So this direct-to-device movement is growing. We know that's a big part of how people think about addressing some of the satellite connectivity, the opportunities that we're seeing now. And the implication, if you're a telco operator, we're at a telecom and partner conference here, is that it becomes a quicker time to market in integrating your equipment with satellite operators who are able to offer this service, and it's a lower cost option. It's not an invasive integration. The OpEx and the CapEx numbers that we're seeing are lower, so it's a quicker time to market and it's a more cost-effective route. So when you combine that volume point I made at the start with the direct-to-device movement, it really puts the conditions towards an increase in the addressable base that can tap in. A lot of people want to talk about Star Wars and the satellite wars of looking at Elon Musk and what is he trying to do with Starlink's constellations. We won't get we'll get into that in the panel, but I wanted to just put a little bit of context on the numbers of what we're looking at. I'll come to China in a minute, but if you look at SpaceX constellation, they are the biggest by far. Both in terms of the actual launch volumes, which is approaching 4,000, and in terms of the planned constellation size for their application, from their application to the FCC. So all going well, in their initial tranche, they shall have about 12,000 satellites. Now Amazon's Kuiper, which pairs with Blue Origin, is about a third of that, and next. The next largest, although it looks to be dwarfed, even though that's a very large number in and of itself. OneWeb, Telesat, and a host of others, many of which we'll hear today, are following in this path. China has a sort of different strategic approach to it, but it does have quite a large constellation plan through its own satellite network group, aligned with government ambitions for controlling connectivity. That doesn't really come into play for some of the direct-to-consumer and direct-to-business applications we're looking at here. So I'm more showing that for reference rather than talking about it as a competitor in the here and now. A bit more color on the coverage gap here. So again, I won't go into too much detail, but this is a chart showing you the population of the world over time, and essentially the share of the global population that is connected. And without getting too much into detail, I just want to make one point from this slide. And that point is, if you look at this green hashed line, that is the incremental change in internet users in the world. In other words, the growth or the loss every year. Which direction is it going? For a long time it was going up. And I'm not showing it in the early 2010s, it was going up. But now it's been on a downward path. So the rate at which the world is adding new internet users is slowing. And that is in large part because of that coverage gap. Not the only reason. There are other barriers, affordability, digital literacy, and others. But that coverage gap is a big part of it. And that's really behind the economics that we talked about from reaching the final frontier. If you look at ahead, so that was now, if you look ahead, so out to 2025, and you can fast forward to 2030 as well, this is sort of what you get. And again, this is being videoed, so don't worry about sort of pulling every last number off here. We'll send this out after. But if you look out to 2025, you still have a coverage gap, this last column here. This is a share of global population that's close to 8%. So it's not even really changing, absent intervention from non-terrestrial network partnerships. Getting that number down is a very important thing for democratizing internet access, having people able to access digital services and other things. But the only way to do that realistically is through some of the partnerships that we're talking about today. And you can see that in the regional breakdowns, the largest coverage gaps will still exist in Africa and Asia, which is one reason why we see that being a concentration of some of the partnerships between operators and satellite companies today. Now we've talked about the strategic rationale for closer integration. Let's talk about some of the financial dimensions to this. So we did some modeling, this is actually from last year. We did some modeling and published a report on direct-to-device 2.0, like the kind of next generation. And without going into too much detail, what we wanted to do was say, if these partnerships that are forming now translate into new users coming online and new businesses coming online, what would that mean from a revenue perspective? Can't be sure, it's just a projection. Projections are made to be broken, but they're there as a context to see it. And what I want to draw your attention to is these numbers in kind of turquoise here. We split them out between consumer, enterprise, and government. And you get to a total incremental value of about $35 billion a year by 2035. And that is the value addressable to the telecoms industry through satellite-enabled connectivity. 35 bill. 2/3 of that come from consumer, just under 1/3 from enterprise, and the rest from government and defense. When you show that as a share of what the total telecom industry revenue is now, it's about 2 to 3%. So it's a material number. People are paying attention. If you could tell a CEO that over that time you could add 2% of growth organically to your top line, they'd probably bite your hand off. So something to pay attention to. Now, again, how that is split out between different operators and satellite providers, time will tell. But that's the sort of magnitude we're looking at. Give you a little bit more geographic color. What we're showing here is if you look at the consumer portion of that, this isn't business, this is just consumer, and you look on a regional basis, what would that translate into in terms of an incremental revenue amount per user? So you look in Africa, South Asia, et cetera, and you get into sort of $3 to $5 range, which again is a material number. Now it's easier said than done. There will be variability on this on a country basis and even on an operator basis, but it gives you a sense of magnitude. And I think one of the things we'll come to in the panel is that we're transitioning to a new phase of satellite where it's getting beyond talking about why this should happen and more into the implementation of the commercial deals that are being signed. So we're going to see global coverage level constellations from, really Q4 this year and accelerating into 2024. So it's happening. We would be remiss to be having this discussion and debate here today, and the panelists will tell you this as well, if we didn't talk about the B2B dimension. We have run a number of surveys. We talk to businesses in different industries, and the use of satellite currently and through their intentions is certainly on the rise. Now, what this is showing is actually a survey data from last year, so it's a bit out of date, but nevertheless still relevant, of asking, would you consider using satellite connectivity for your business? I wasn't expecting numbers like this. I was frankly quite surprised. But you look at that and you're looking at sort of 15, 20, 25%. I would discount these a bit. When you ask people survey questions, they don't always answer entirely truthfully, but even if you took that off by half, that's a big number. And the question then becomes, well, what use cases are being demanded here? Well, we're seeing a lot in things like precision agriculture, the use of drones for pesticide control. We're seeing a lot in logistics and automotive. trucks and other vehicles transiting across national boundaries and needing seamless roaming. We're seeing some in remote healthcare, particularly in regions where there's less hospital infrastructure and road infrastructure to get people to those hospitals. So this promise is there, and again, I think this is going to be something really interesting to watch over the next couple of years as partnerships come online to fruition, how businesses are served. In the modeling we ran last year, this is an output from it. A lot of people like to sort of say a big number and just sort of walk off the stage and sort of have people be impressed, but it doesn't really matter unless you put it in relation to something else. So when we look at the IoT space, like we forecast right now that by the end of the decade, there will be just under 40 billion IoT devices in the world. Not satellite enabled, total. That could be a connected car, it could be a sensor, it could be something else. It's a big number. If you look at that question from a satellite perspective, so asking how many of those IoT objects could potentially be serviced by satellite connectivity, this is sort of what you get to. And we got to 2 billion. 2 billion, which is about 8% of the market now, a little bit lower as that overall IoT share grows. But it's a significant number. And here is the sort of industry breakdown you get of those 2 billion IoT devices serviceable by satellite. A lot in remote utilities. This is anything from utilities on private premises through to solar generation and wind generation. Low power use cases that don't necessarily need high bandwidth, high speed connectivity. We see some in automotive. I talked about that in logistics. A lot in where sectors are off the grid or operating in remote areas. This is mining installations, offshore oil and gas drilling. We're already seeing a lot of implementation for satellite in these areas, and I have seen them for myself. This will likely scale up. And we see some, as I talked about, in healthcare. Takeaway point from this chart is it's not a one-trick pony. This is something that is a transitional shift of a technology that can affect many different industries. And I think that's a recognition that perhaps wasn't appreciated to the extent that it should be a few years ago. And I think that's really interesting to see that change. All right, we'll get to Ken in a minute for our first keynote, but this is the last slide I wanted to show you on the context portion of this session. So I started off by saying, why does satellite matter? Why should people care? Let's come full circle and look at where it goes from here, and we don't pretend to have all the answers, but what are the open questions? Because that's ultimately why we're here. We want to talk about the open questions that people have. Now, let's split them out between technology, business, and regulation. And you may have others. We'd be interested to hear from you as well after the session on questions you have. Starting in technology, can satellite connectivity get beyond 3 or 4 megabits per second? This is a question we're often asked, particularly, and Paul will talk about this for Globalstar's partnership with Apple. If you are going to have satellite taking a larger share of the market, at some point, you're going to need to offer people more comparable speeds to LTE now. How do you get there? How does that happen? Does it happen, and how do you get there? Interesting question. For the constellations themselves, can they stay up in the sky longer? And can you reduce space junk to take away the risks associated with that? Is direct-to-device the real deal? I talked about the standards integration. Does that happen and filter through to the addressable base? Here's an important question. Will we see the reporting come through from mobile operators splitting out people who have been connected through satellite? Haven't seen a lot of that so far. That'll be a key proof point. So a number of areas in the performance. Partnership, does this remain a wholesale story? Does this remain wholesale, or do we see more offerings going direct to the consumer or direct to the business in a retail offering? Important question, and of course proving the revenue story. Regulation, there are a lot of questions, and we'll talk about some of these in the second panel around satellite spectrum use. We're starting to see sharing and licensing of terrestrial spectrum, new models of spectrum use, compared to just MSS, KU, KA band. Where does that go? And how do the standards become aligned with 3GPP towards 6G? So not just 5G, but also 6G. So there's a number of open questions. Anyways, I'm going to end there. We're coming up on 10. That hopefully sets the scene. What I would like to do now, though, is welcome to the stage our first keynote speaker, which is going to be Ken Peterman, who is the CEO of Comtech. And Ken, welcome.
All right, thank you. Listen, you can hear me all right, right? Okay. I come at this, and this comes nicely on the heels of Tim's briefing, because I come at this after 40 years in this technology sector. The first 20 years of my career, I worked in the defense industrial base, and we were creating things like satellite communications, mobile networking. We invented things like cybersecurity and global positioning system. And largely that was so that our sons and daughters on the battlefield could communicate to their buddies, could understand where they were and where they're going, could have a certain situational awareness. And it was really hard. It was only with the power of the taxpayer's purse and an enormous amount of technology trial that we managed to create capabilities that are in the field still today. GPS, mobile networking, satellite communication, cybersecurity, all those things were invented maybe in the first 20 years of my career. The second 20 years of my career, we watched something amazing happen. Okay, these technologies were embraced by the private sector. And we saw the emergence of satchel phones, followed by flip phones, followed by smartphones, followed by the BlackBerry, and then maybe eventually followed by the smartphone. We saw the proliferation of ground networks, Wi-Fi, Bluetooth, cellular, and the progression was enormously rapid. It happened on an accelerated pace, faster than anything the government procurement models could do. And what we see now is we're on the cusp. We're on the cusp of enormous change. We're on the cusp of bringing terrestrial and satellite or non-terrestrial together. We're on the cusp of standardization. We're on the cusp of digitalization and virtualization. We're on the cusp of bringing the physical and the virtual worlds together to create a world that's not like it's like none other that preceded it. And we're on the verge of connecting the unconnected, democratizing data, making access to education and healthcare and all the things connectivity provides. We're on the cusp of bringing that to everyone, such that no one's left behind. I find myself today CEO of Comtech, a company that is deeply involved in these technology sectors. About half of our business is in satellite communications, about half of our business is in terrestrial and wireless networking, and the capabilities in terrestrial and wireless networking have proceeded differently than in communications, in part because those markets have been completely different and independent ecosystems. The companies involved in those markets have been completely different companies, and frankly, the markets they served were completely different. So we're seeing now a convergence of these two markets, and it's literally changing the game. But what I want to do is I want to offer a couple of prepared remarks, because I think that the consortia, the community that has brought terrestrial networks together and standardized around waveforms, standardized around interfaces, brought it forward in a way that was not geographically sectored off, but was homogeneous on a global scale. That work is really stunning. It's really remarkable. And I want to speak to that just briefly. First, we have a significant role in that. We handle about 60% of all 911 calls. We provide location-based services of where all the connected devices are on the network. We do a variety of things in the terrestrial and wireless community. And then in the satellite community, we build everything associated with ground terminals, hubs, and ground systems. We build modems, bucks, channelizers, amplifiers, antennas, and the whole ball of wax. So we come at this looking at it through a very unique and broad lens that's probably different than almost any other company in our market segment. So having said that, let me say that today we're bringing forward hybrid blended network architectures that democratize access to communications and deliver new insights and services to really empower a connected world. I want to talk a little bit about how we can bring that together in a more powerful way. It really starts with digitalization. Enterprises, government organizations, the connected world is predominantly moving to digitalization. Digitalization is also a core enabler to hybrid services. Enterprises are enabling and embracing digitalization such that they have the ability to easily update and adapt to evolving network demands, evolving user and subscriber use cases. Not only is this going to expand access to 5G NTN connectivity, but digitalization can transform traditional connectivity into new layered value-added services and applications. Think about cloud-native service providers and whether mobile network or satellite examples exist. So digitalization is an empowering capability. The other thing is open standards. You see that in the terrestrial domain. You do not see that so much in the satellite domain. In fact, if you spend a moment, because I spend a lot of time in the satellite domain, and maybe some of you are new and just dipping your toe in the water there, let me say that satellite operators initially didn't sell bits. They sold megahertz. In fact, they sold bandwidth. And the buyer of that capacity had to develop their own waveform, their own modems, their own user devices in order to connect to that satellite network. Typically, those devices, those waveforms and the networking algorithms, the security protocols, the user interfaces, all of that was tailored to the specific use case that that individual satellite provider wanted to serve. So there was absolutely no standardization. There was absolutely no ability to roam freely among different satellite systems. It was all developed in a stovepipe, siloed manner to serve a specific customer community. As high-capacity satellites came into play, and I mean satellites, let's say that, I don't know that any satellite in geosynchronous orbit, and that's where the original satellites were fielded. Geosynchronous orbit means that the satellite is positioned 23,600 miles above the Earth, about 30,000 kilometers. And the reason they put them at that altitude is because the gravitational pull is such that the satellite will remain in place. There's a little bit of station keeping involved to keep it positioned right, but basically it hovers right above the equator of the Earth, and it stays above the same point in the Earth all the time. So as the Earth rotates, that satellite rotates with it, and it's always got the same coverage area. High-capacity satellites started to emerge in about 2013, and it was a fundamental change in the architecture of the geosynchronous satellite. Fundamentally, all satellites had been architected like broadcast television. A big, powerful signal, common to everybody, and it was broadcast in megahertz. High-capacity satellites came about in about 2013, and it really started when they re-architected that satellite, and instead of making it like broadcast television, they architected it like a cellular base station. Cellular base station's fundamentally different. Cellular base station's able to connect tens of thousands, hundreds of thousands of users, and each one essentially has a sense that they have a private and individual connection experience. The data they're downloading from the web, the phone call that they're making, they have a sense that it's private and it's an individual connection. They did that by frequency reuse and other techniques that I won't get into. But the bottom line is satellites all of a sudden had a capacity of not just 12 gigabits per second, but they had a capacity in the terabits per second. And that's what you're seeing today. So they can serve enormously larger number of users. Now, those satellites were big. You have to think in terms of a double-decker bus with solar panels that span a wingspan of a Boeing 747. They take $1 billion or more to make. The launch cost is expensive. They're on orbit for about 20 years. That's their service life. And they have a term called space hardened or space qualified. And that's because when you put something that costs $1 billion in space and you can't send a repair truck up to fix it, you've got to have redundancy and all those capabilities in that satellite. Now, when launch costs came down and new space emerged, and Tim talked to this about the prolific number of satellites in low Earth orbit. Low Earth orbit is just in the hundreds of miles above the Earth, and the satellites are actually orbiting around the Earth. So one thing you have to look at is the orbital plane that you launch them on. If they orbit this way or they orbit this way, because they're so much closer to the Earth, the coverage area is much smaller. So you have to be very thoughtful about the user community that you're trying to cast in order to connect your business case and the types of services that you're going to offer. The second thing is those LEO satellites in low Earth orbit suffer a significantly greater gravitational pull. So they have to exert propellant and they have to exert energy to apply that propellant, and they only have so much. A typical, I mentioned that a geosynchronous satellite might be the size of a double-decker bus. A low Earth orbit satellite might be the size of this podium. So it has much less capacity, it's much smaller coverage footprint, it's much closer to the Earth, and it is exerting propellant, it's exerting energy every day in order to stay in orbit. That's why a LEO satellite has a useful life of maybe 4 years, maybe 5 years. So think of this. If you're one of the LEO providers that Tim talked about earlier, Amazon Kuiper, Starlink, and you want to field 4,000, 10,000 satellites, you're basically replacing a third or a fourth of that entire constellation every single year. Now there's a cost associated with that. And because your satellite's smaller and you have less bandwidth, your subscriber, you've got to be very attentive to your business case. Now, the other thing that's significantly different about LEO, though, is that replacement is an opportunity. Because while a GEO satellite is in orbit for 20 years, a LEO satellite constellation replaced its entire technical baseline and goes from Gen 2 to Gen 3 to Gen 4 about every 4 or 5 years. So you have the opportunity to replace the entire constellation and tailor your technology envelope, tailor your capability envelope, tailor the capability you're providing user subscribers to evolve over time to keep pace with changing user subscriber patterns, changing cyber threat vectors, accelerating technology trajectories, or whatever it may be. That requires you to do business differently. GEO satellite operators would buy their ground infrastructure once. They would design the architecture themselves. They would reduce that ground architecture down to a spec for the modem and a spec for the amplifier, a spec for the antenna, et cetera, et cetera. And they would basically compete those products on price because it was a commodity game, and anyone that could meet their waveform spec, anyone that could meet their other technical performance parameter was just fine. And the geosynchronous satellite providers would live with that architecture for 20 years. Because since you couldn't change the satellite, there's no reason to be mucking around with the ground infrastructure and spending money replacing that. What did become challenging is to operate over different waveforms and to engage different subscribers. Geosynchronous ground earth stations sometimes were very expensive. Sometimes were $5 or $10 million because you had racks of modems of different types that implemented different waveforms. You had racks of antennas. You had all of that. And in fact, if you needed 200 and 250 ground stations and they were $5 or $10 million a piece, that became a significant economic burden on your business case. Now, LEO operators are different. Because LEO operators can change their technology performance envelope and reinvent their space constellation about every 5 years, they need a ground infrastructure partner that's completely different. They need one that is virtualized. They need one that is digitalized. They need as much of that ground infrastructure done in a cloud-native environment as they possibly can because they want it to evolve over time. The other thing that happens is that ground infrastructure is the natural lens through which you gather data on how the network is performing, where stranded capacity is and how to put that capacity to work and monetize it, how your end user or subscriber usage patterns are changing, how your cyber threat vectors are changing, and all of that. So the LEO satellite providers, instead of buying the hardware to a spec one time, the LEO providers now start looking at virtualized ground infrastructure that's digitalized, applying open architecture, applying open standards, applying open waveform standards. That's where the migration from 5G to 5G Advanced to 6G really comes into play, is as we blend satellite communications and terrestrial networks. We move to now the satellite operators begin to move toward common standards, common waveforms, common networking protocols, so that these architectures can be truly blended. In some ways, the 40-year history that some of us have in these markets put us in a position to drive companies to be able to support and advocate these kinds of open standards, these kinds of open interfaces, this kind of virtualization, digitalization, and driving to be cloud native in these ground infrastructures to enable this. Because a user, now if you look through the user's lens, the user of a mobile device does not get involved with network or data routing. They turn on Bluetooth, they turn on Wi-Fi, they turn on cellular. And because then there's a smart, intelligent decision engine inside the mobile device that knows that a certain app needs to be routed over Bluetooth, another one needs to be routed over Wi-Fi, something else needs to be routed over cellular, and now with direct-to-device, some of that can be routed over a LEO satellite as well. But what the user is not getting yet is a full-service satellite connectivity that I believe the open standards and the terrestrial community that has driven 3GPP and the 5G Advanced and 6G, the ones that have driven that to be homogeneous, the ones that have benefited the user community with that kind of standardization, that needs to come on to the satellite community, and that's going to come on fast. And the reason, because the satellites operate differently. If a user is downloading Netflix data, they need high capacity, and they're not going to get that from a LEO. They're going to have to get that from a geosynchronous satellite. So just like they have Bluetooth, Wi-Fi, cellular, and satellite, it's not just satellite. They need satellite with high capacity, like a geo connection. They need a satellite with low latency for online gaming, and that's a LEO connection. So this kind of a smart decision engine and this kind of standards-based, homogeneous networking infrastructures across on a global scale is what I think the path to 6G starts to bring us. Now, I'll get off the stage in a minute because we've got a panel coming, and these subjects need to be delved into in a serious, thoughtful, technology-centric manner. And I'm glad to see organizations like this sponsoring that and doing this. I can tell you that those of us at Comtech are thrilled to sponsor this event. I think that the community that has done such a fantastic job in the terrestrial network infrastructure now is starting to turn its attention to the satellite community, which is a completely different ecosystem. I also think, by the way, these convergences, we're seeing convergence of satellite and terrestrial. We've talked about that. I think you're going to see convergence within the satellite community, convergence of communication satellite constellations with geospatial imagery and EO and Earth observation satellite constellations. If I was going to field a 10,000 LEO satellite constellation, I would be serving the communications market. I would be serving the geospatial imagery market with a package on each satellite. And I'll tell you what, I'd even look at doing some processing in space so I could get insights to the edge, not just push data to the edge. That's what's coming next. And the trajectory that I think this body's on is the right path. It's not going to be easy. There's a lot of inertia that's got to be overcome in the satellite community. But we are going to partner with you and lead the way. Thanks very much.
Move into the first panel. So we are going to get into more detail on the telco-sat integration and sort of some of the topics that we've been getting in so far. So joining on the stage, we're going to have Anirban Chakrabarti, the CTO of Comtech, Ken's colleague, Amina Bubendir, Head of Research and Standardization at Airbus, and Mahmoud Kafaji, the Director of Product Management at Link, to help go through this topic. So guys, come on up to the stage, please. Just take a seat over there. Hey, good to see you. So as I said, we've got 40 minutes for this panel, and we've got plenty of questions for the panelists here, but part of the way through, I will break and give you guys a chance to ask questions. There are a lot of you here, so when we do that, if you want to come up to the front, we'll just pass you this mic for a minute and you can ask the question and then we'll put it to the panel as we go. So just bear that in mind as we go through. All right. Well, guys, thank you very much. It's really great to have you all here today. It's a lot of interest in the topic, and I know the three of you bring different perspectives. So we're talking about, why this is happening, why the movement is gaining pace, and sort of expanding on some of the topics we've talked about before, but ultimately where this goes. And maybe if I can just kick off, and I'll ask this to each of you, just give me your perspective on why you think the market is the momentum is growing and why more telecom operators are interested in partnering with satellite. So maybe Mahmoud, do you want to kick us off?
Yeah, absolutely. Yeah. So I'm Mahmoud Kafagi. I'm the director of product at Link. Link, we're building cell towers in space. Those cell towers are capable of connecting to all the phones we have in our pockets right now. It's backward compatible with more than 5 billion devices out there. We've been doing this for a while. It's been over 6 years since we started this journey. And what really kicked things off is just over a year ago when Apple came out with the SOS feature on the latest iPhone. Yeah. So it kind of whet the people's appetite on, now I can connect my phone to the satellite. Yes, I can use it for emergency.
Oh, you got to keep it closer to your mouth.
All right. Now I can keep it for emergency purposes, but I really want to be connected everywhere. And that really kicked things off, and we've seen a lot of traction ever since. So ever since, we've signed more than 30 mobile network operators in more than 50 countries. And we're in commercial service right now. So,
Amina, do you want to go next?
So I think both satellite and telcos are interested in the merging, in the convergence. Probably the UN, I really believe that the UN SDGs and some social and economical stakes that we're talking about in Europe, in the US, so worldwide, are pushing for enhancing different areas of the social life, daily life, business as well, economical aspects. And both satellite and telcos are aware of the advantages that this merging could bring. So both the demand and the technology push that all the players from both industries are pushing for make a very good momentum for this convergence. The fact that 5G is already there and 5G advanced being specified would bring to the satellite new use cases that the satellite industry today doesn't have, and I really appreciate the examples that you gave are really the ones that will remain there for the industries that still will always need satellite connectivity, but not today are not allowing for broadband and real-time services, and this will be brought by the 5G Advanced. And on the other side, the telco are looking or should look at the satellite connectivity as an extension to their footprint, to reachability, breaking the digital divide, but also just extending the footprint is something that, from the business perspective, can be valuable to them. We can develop later.
Yeah. Anirban, do you want to round us out on that question?
Sure. I'd say, there are multiple dimensions to this question. Obviously, the digital divide, you talked about it, Tim, how much of unserved or underserved we are today. But I think, in general, the ecosystem has realized that, A, the society needs better stuff, whether it is education, whether it is public safety, emergency healthcare, or even from an enterprise, digital transformation or whatever we call today is Industry 4.0. At the backbone of it is connectivity. But secondly, I think 5G is also telling us that, guys, we need to move and get away from one network that fits all. So we need something which is, it gives us assured connectivity, but not always on, but always whenever it's needed. So on demand, scalable, and that's where I think both these ecosystems, satellite and terrestrial, they realize that we are probably stepping into that age where we should accept the fact that we alone cannot do everything, right? There are challenges, but I think on a holistic level, and this is this year in MWC Barcelona, I saw so many satellite operators which I had never seen before. So that to me was also, a kind of a refresher that everybody is coming together to build this ecosystem, not just for the sake of, hey, does it give us a better business or enhanced coverage, but I think the aspect is, does it give us a lower total cost of ownership? How do I define in such a fashion that I still drive the cost per bit down, extend my coverage, extend the number of customers I have, but do this all through a partnership ecosystem. So I'll sum it up like that.
I think one of the questions people will naturally have about when we talk about so everybody's agreed on the partnership ecosystem as being the way forward and a big part of it. Kind of building on this first question of why is this happening, like, how much do you think you can put some of the acceleration down to technology improvements versus demand drivers, like people, consumers or businesses wanting the connectivity? And can you separate those, do you think, or do they both go hand in hand? Maybe Amina, your thoughts?
I really believe it's a circle. I really think they go hand in hand. Research and development don't stop, and similarly give ideas to users about how to use technology in their daily life. And on the other hand, users have growing expectations about technology, so they're pushing for usages that even technology developers may not pre-envision. Right?
I think it's supposed to speak. This way. Yeah, we just move over here.
So maybe I can speak louder.
Yeah.
So yeah, it is a circle in my opinion. But so the second part of the question is how to do that. I think the standards aspect is really important. It is obvious for the telcos. They achieved worldwide interoperability at the network level, but went up to the application with the web, right? The satellite industry is still very much vertically oriented, very integrated, vendor specific. But we're going, and I think the digitalization and virtualization are very strong enablers, but like more encouraging aspects and probably just impacts from the other industries to push the satellite industry to go into standardization. It's not because they need interoperability, but between them, but they need interoperability with the 5G and the telco players. So today the integration is just through backhauling. But we're, for example, if you know IEEE DIFI, which is the Digital Intermediate Frequency Interoperability, has already 2 standardization releases, and is working on the cloud run of the satellite. That's how I would call it. But also within 3GPP, the release 18 will be issued in December, and the release 19 is already looking at the regenerative payload, and we had the very first study item regenerative payload approved 2 weeks ago in India. So that's a major milestone, and I could tell, even though maybe the telco partners are here in the room, I could tell how they were somehow against this. But we needed to discuss together, and we managed to do that and have this study item approved. So that's the standard and interoperability are ways to push maybe a long-lasting foundation to all these evolutions and help the users get the best out of it.
Watch that there. Mahmoud, maybe from Link's perspective, I mean, can you talk to the demand you and your partners are seeing in consumer versus enterprise, and how do you see those two segments playing out going forward? Do you think one is a bigger market for you, or do you see them both kind of as profitable?
Right. Yeah. I think the short answer is both. Right. So MNOs are doing their best to build towers everywhere, provide connectivity, but that's just not possible, whether economical reasons or you just can't build it because it's top of a mountain or middle of the ocean, that type thing. So we see demand from both the. Okay. We see demand from both the consumer side as well as the business side. So from the consumer side, people want to be connected everywhere. There are still gaps of coverage that, as I said, can't really be fulfilled today. But also from an enterprise perspective, a lot of IoT devices like require connectivity, whether it's in rural and remote places or when MNO, especially in developed markets, shutting down their legacy networks and they're looking for kind of the extra layer of connectivity from space to connect those IoT devices. So we're seeing both in the marketplace for sure.
Anirban, same question to you. I mean, and maybe, sorry about the audio, maybe even more on the enterprise. I mean, can you speak to the sort of use cases, demand you are seeing through your customers for how this is going to be taken up? Like maybe some specific examples of different use cases that are gaining more traction than others?
Yeah, so I'll touch it. Maybe I'll take 2 steps back and try to recalibrate a thought here. I'd say 4G era that gave us the applications such as Uber and Netflix, right? So those, as people call them, killer applications. But net amongst all of us, when we start talking about or even start thinking about customer experience, we subconsciously attach that customer experience to the downlink speed. We always think that how much speed I'm getting, if I'm getting it at this spot or that spot. But I think we are looking at an era where the customer experience is going to get recalibrated to uplink as well. And this is where enterprises will start to come in when they are uploading tons and tons of data. So that's one area, and obviously, if you ask me that, okay, give me one straight example of an enterprise use case, I'll not go to the industry, but I'd rather come to the society, to the human values. Talk about emergency disaster situations. Whatever storm hits us or tornado hits us in whatever part of the world, the mobile towers get affected, and I think that to me is the fantastic and the first use case where a 5G NTN, as we roll out, and as she was saying rightly so, that by the time we hit into regenerative payload and start enabling things like NTN to TN mobile handovers, we will start looking at a better realization of public safety, better realizations of towards health and safety of the citizens. Not to mention, obviously, remote oil refineries, and Ken pointed out 5G to 5G advanced to 6G. We are getting into this culmination of physical and digital world. Each of these things are a step towards that, in which we create that ecosystem which not only starts to celebrate the downlink aspect, but also being able to create tons and tons of upload or uplink data that these satellites will be using. But I think at the crux of it, the important question which we all need to understand is the aspect of the experience from the latency standpoint. So not diving much into that, but I think those are the key takeaways from my side, to be honest.
And just maybe one follow-up question to that. When you talk about uplink capacity being part of the future, I mean, how would an operator treat that as a sellable asset and sort of be able to market that, or is that more of a technical feature, do you think?
I do not know. I'll be honest. I do not know how the go-to-market will happen on this. Obviously, this is a service, but I would like to talk about it as an outcome. I would like to talk about it as an experience, and it definitely recalibrates the fact that, are we selling an outcome, a business process outcome to an enterprise, or are we selling connectivity, right? So there has been a conversation that, okay, the satellite ecosystem changed gears from selling megahertz to megabits. Okay, fine. And now what? Now are you going to? We looked at so many use cases of late, wherein smart agriculture, right? So why do I need a connectivity in smart agriculture? And I think that's what the question is. Are we going to talk about a tractor being able to plant or sow seeds very close to each other? And is that something I'm going to enable? And once I have enabled that, is that uplink data going to be used for some sort of analytics in the future? That's the question to be answered. Not necessarily the how piece, but the what or the end game piece. That's
Right. Let's come to the audience. I've got plenty of more questions, but is there anybody here who has a question they would like to ask the panel? Yep. Okay, sir, why don't you come into the aisle, and then we'll pass you this.
Wow.
Okay, yeah, please.
So my question is, I heard, Tim, in your opening about the use case scenario with so many underserved people. You said 34% of the planet doesn't have a cell phone, 8 to 12% lack coverage. That's a business driver. But it sounds like from the panel that we're really looking at the question about whether this is a feature for existing users, right? Like satellite connectivity. So is there really a use case to get the underserved, or to make all the money adding another feature to my expensive phone for that whole market? And I forgot to say, I'm Patrick Wilson from MediaTek.
Thank you. So just to repeat the question for anybody who didn't hear, he's asking, how do we think about the use case of bringing people into mobile who haven't had a phone versus adding to the experience of those who already do have a phone? Now, I'll come to the panel in a minute. Just one clarification. So the 34% isn't 34% of the world who lives in a coverage gap or who doesn't have a phone. It's the 34% is the share of people who are not on the internet for whom coverage is the primary barrier. So just minor point, but it's a good question. It's a good question. So again, maybe we can come back. So Mahmoud, do you want to start us off on that? So how do we think about, is this a false dichotomy? Do you need to think about bringing people online differently from adding roaming to people's plans who already have it, or how do you think about those two?
Yeah, so I think it's both, right? So in conversations with MNOs, so they're thinking about it for go-to-market in two ways, one of two ways. So one of them is they would add an additional, some sort of tariff or something and allow their subscribers to have connectivity where there is no coverage, or they may have it in their existing plans, right? So we see that. But others may look at it differently, where they want to acquire more subscribers, especially in rural and remote places that don't have phones, and they see that as an opportunity to add more and more subscribers, and it's better for their revenue in general and average revenue per user. So we certainly see both. Obviously, it's different percentage, depends on which part of the world, but absolutely we see both. Yeah.
Quick follow-up on that, and I'll come to Mina in a minute, but when you're talking with your partners about, your operator partners, about, say, roaming, have they given any indication as to the sales strategy for that? Is that something that would be bundled into an existing tariff, or could that be chargeable as a premium?
Yeah, so there's lots of ways MNOs go to market with their subscribers, and it's obviously different per country. So in a sense, a lot of it is similar to roaming, where this would be an additional type of tariff, like roaming is today. Like when you travel abroad, you pay per day or per week of usage or month, or you may do like in a pay-as-you-go type service. So it really varies a lot, and some of them see this as kind of an advantage over their competitors, where they would add in, they pretty much include it in their existing bundles, and that would give them the edge over their competitors. So,
do you want to chime in?
Which question?
Well, the gentleman's question around how do you think about satellite's value in terms of bringing people onto the internet and phones who haven't had it versus if you already have a phone, adding new features to that service?
The first part where we would tackle the underserved, it's probably not the people who don't have any mobile phone at all, but just the areas where there is need for connectivity, but it's not there as it is needed. For example, in some countries in Africa, Meta has deployed fiber optics, which is already an enabler for satellite, because it will be the transport network for a satellite coverage. So those areas, and this is where the collaboration, so Meta is everything, is not just an operator, but this partnership and this merge and this convergence is definitely needed to cover the underserved, but the ones who are fully out of reach, I think that goes to the UN SDGs development, the UN development sustainability development goals, and I would link it to the Space 4 SDG. So there are initiatives with the European Space Agency, also with NASA, on how space can serve the UN SDGs. So it's literally called Space 4 UN SDGs, and there are initiatives that are rather in research. The ones I know about are rather in research and relying on research market and social statistics. But the second part, which is just adding features for now, and before we reach full interoperability, it will, I believe, it will remain bundles and offers between satellite operators and telcos, and it's already existing for IoT services. Devices, 3GPP devices, so with SIM cards, already covered by some satellite operators, small new space satellite operators for IoT, non-real-time and non-broadband. So we're touching again back to agriculture, long-range use cases with low volumes of data, but they're growing this because they do have a 5G core network on the payload, and they can extend this to real-time, store and forward, but real-time and broadband. Yeah.
Anirban, do you want to chime in?
Yeah, I think I'll echo with what Mahmood was saying. I think this is going to happen in both ways. So unserved, obviously, we have to make sure that there is a connectivity there, albeit it could be just a narrowband aspect. But on the other side, to the question he asked, if I want to have another subscription, or let's say another feature that, okay, if I am traveling on a cruise ship with my family, I need to get that. It is very similar to that a roaming example that Mahmood was talking about. I mean, I'm not roaming necessarily out of the country, but I'm in a place where there is no cellular connectivity, but I still want to be able to purchase that, or let's say even add that. So I think both those models will exist at the end of the day. Now, how that will be enabled and what could be other repercussions to that is that, for example, I mean, let's say I add this extra features of being able to connect with a satellite network. Does it mean that I'll be able to switch or select the carriers where I am getting myself connected on, even if I'm connected to both the terrestrial and non-terrestrial networks? So I think those possibilities are being looked upon. MNOs are talking about that. Satellite operators are talking about that. So that, in essence, it all boils down to how is anybody going to monetize this whole thing? You touched upon the fact that is it going to be a wholesale business? I don't know. To be very honest, we don't know all of those answers today. But these are the possible questions one need to stand up and ask today.
I mean, yeah, sir. Do you want to stand up and just let us?
Okay. The other question I have is, you were speaking about convergence, standardizations, and the benefits of all this, because that's what we saw in the GSMA world. How about Starlink, Kuiper? They are fully integrated.
Yeah.
Are they cooperating?
Yeah.
What do you know about this, or are they doing everything on their own and they will stand?
Yeah.
Okay. What's the
Right. So the question here is around vertical integration. So the gentleman is asking, he's citing that Starlink, Kuiper are vertically integrated companies because they can control the launch facilities, they can control the rockets, they can control the satellites, and to a certain extent the ground station infrastructure. How much is that does that rely on others, and can other companies sort of pursue that model? Is that a fair reflection of the question?
That's one thing.
Yeah.
The other thing is, do you think they will come to the cooperation with the regulation?
Okay, yeah, and a follow-on, does that bring them to the table on standardization? So we touched on this before, and part of what I was trying to get at in the opening presentation of the changed economics are exactly because of this. When you can not have to subcontract launching a rocket or other very, very high costs, you can get to a greater scale quicker. Amita, you work for a big company. Do you want to start on that one? And also maybe if you could comment on the standardization point is valid as well.
Definitely. So that's the example we got a lot. So Starlink is not 3GPP compliant, but it works. So why are we waiting for 3GPP specifications to develop new constellation 5G SAT architecture? That's true, and I really believe it's like more of a culture and a cultural mindset. In the US, if you have the capacity to invest and deploy, you do it. In Europe, we're more of standard-oriented, and we wait for everyone to have the same standards, and then go wait for policymakers, and then do the things like properly. So that's a true debate, standardizing or not standardizing. So if it works, and Starlink has been used for military purposes in Europe, in Ukraine, for example, so okay, viable enough to be used. Why are we waiting for 3GPP? Probably the answer, but it's a long debate. Short answer to that would be, it is important for the mass market. We need this interoperability for the large scale. For the mission critical or the military satellite communication aspects, everything available and working can be used because the need is urgent. Sorry? It's both.
Did they come to the table of negotiations and implementation?
They're not present. Starlink is today not present in 3GPP. OneWeb is. OneWeb, the first generation of OneWeb is vendor specific, but the second generation, they're going for 5G SAT with 3GPP standards. They're not present.
That doesn't mean that won't happen.
Yeah.
But there's a force of gravity effect here that history tells us will play itself out over time. But there's commercial reasons as to why it hasn't happened yet. Do either of you guys want to chime in on this one?
This is a great question, and I think I look at this question step one as you mentioned, vertically integrated, right? So I look at it from the satellite satellite standpoint. So at one hand, we are talking about, hey, do we take the satellite? She mentioned about Diffie. So we're talking about digitalization of the ground infrastructure, being able to do multi-orbit modems, being able to, create waveforms which are either VNFs or CNF. So vertically integrated, whether you talked about Kuiper or Starlink, they are obviously in that domain where they don't, quote unquote, yet support that. But that's one. The other thing is will they have a handshake with a terrestrial? And if so, what does that mean? Today they are not. But there is a flavor from a Starlink perspective. If you go and talk to them, they will say that, hey, I do support a 4G LTE. What does that mean? We don't know. There is some discussion somewhere that, okay, is there a E-Node B up in the sky from a Starlink perspective? Is that 3GPP standardized? I would agree with her, it is not. Will they ever come to that? I don't know. But is that the right approach given where the industry is going? That's the question. Both Kuiper and Starlink, they are not, in line with this conversation we are having from, hey, what's the path from 5G to 5G advanced, where does NTN fit in, and then 6G? They have not, I don't think so, they have subscribed for it openly. Will they?
Yeah, so we have a different perspective on that. We actually see all these players as complementary to what we're doing, right? So from a user perspective, let's take a step back. How does that look like? So if you buy a Starlink terminal or a OneWeb or a Kuiper and put a flat panel antenna or some sort of dish on a rooftop in a remote place, it will give you Wi-Fi hotspot where you are, right? So this is great if you can afford it. Once you go outside of that Wi-Fi hotspot, then this is where connecting directly to a satellite comes into place. So we do see them both complementary to each other's, and we've seen MNOs using, more specifically Kuiper and to some extent OneWeb as a way for their backhaul for their terrestrial cell towers in remote places.
Satellite or on ground terminal. Obviously, a phone is already defined.
sure if I followed the question.
Do you want to IPR fees? And by IPR you mean
3G, 4G, 5G, IPR fees.
What does that mean?
Yeah, okay. Tricky one. It's an interesting one. I think that's probably one to take offline, just because that will be a heavily commercially weighted story. It's valid, but that'll vary case by case. Maybe we can check in with you after the session on that. If that's all right. Let me take one more from the audience, and then I've got a couple more because I'm conscious Paul's going to be coming on in about 10 minutes. Yes, ma'am. Do you want to come up a little bit closer?
In terms of satellite to smartphone connectivity, SpaceX is trying to put to, how many LEO satellites do they put to? Does it depend?
Okay. Okay. So the question here is around the TMO SpaceX partnership. And her question is looking at how many satellites would need to be in space to make that, to service a given ground population with a given throughput. Now, mathematically we can answer that question, but it will ultimately depend on the level of ground throughput they are looking to provide for a given level of their customer base. Do you guys want to, I obviously no one's party to that transaction here, so we can't give specifics on the actual constellation volumes, but maybe you could speak about, how to think about that question. Mahmoud, do you want to start us off?
Yeah, I can answer from our perspective. So there is like 3 inflection points in our business, right? So inflection point number 1 today, we have 3 satellites in orbit that are operational and providing commercial service to subscribers today. So these are all in low Earth orbit, so they travel the entire Earth. So they can provide 100% of geography coverage. The problem is it's for specific time at a time, right? So you get a few overpasses a day with 3 satellites. And as we grow the constellation, the use cases are going to increase, and we're going to have a lot more subscribers to serve until we get to the second inflection points, which is what we call seamless messaging. What that means is the time between overpasses is really, really, really short. And from a user perspective, you would send a message and it go through. It may take a few minutes to go through, but it will go through without the phone timing out. Right? And the last inflection point, this is when we have enough satellites in orbit to provide continuous connectivity, and then like you would be able to hand off the data session or the voice call, and at that point you can offer voice and data. The satellites are capable today of messaging, data, and voice, and we've proven that. It's all on our website, and some of our MNO partners have tested this and out talking about this. So it really depends on where you are across the globe. Just high level, on higher latitudes, like for example in Canada and maybe New Zealand and Australia and South America, Argentina or Chile, you get a lot more overpasses a day, or you get faster to that kind of continuous service than at the equator. So it really depends, and yeah, so that's
The similar answer to Mahmoud. I think it's more of a physics question at the end of the day. It depends upon number of satellites, and I would also add a little bit of the orbital regime, right? So is it like this, or is it like this around the Earth? So and I guess that's where we see the LEO constellations. In one of Tim's chart, we saw the hockey stick kind of a graph there, that these guys are sending thousands of because the launch cost has drastically come down. More of a physics question, and as the services start to go up, and if we drift down to 5G NTN for the sake of this discussion, right now we are only doing what I call is a narrow band, right? So sub 6 gigahertz, or what 3GPP calls as FR1. By the time we reach release 18, 19, and we start looking into more of EMBB kind of Ka band kind of aspects, that's when I think that physics question also will shift, because then there is VSAT kind of terminals which are downloading this and providing indirect access to UE. That's when different business models, different go-to-market strategies will come. Not necessarily. In many cases, there could be a possibility that indirect access to a UE via a VSAT serving as a 5G NTN node will be proliferated as well.
Amina, I'm going to start you on the next question, but so we've got 5 minutes left in this panel before Paul Jacobs comes up. Were there any other questions in the audience? Okay. Do you want to have? Yeah, well, ask your question, sir, and then I've got one more. Yeah. So the question is around device standardization, and will devices be certified to the standard overall or to a given constellation? Amina?
To answer the question from the gentleman, in 3GPP, device makers and chipset makers are are the ones that are supporting the 5G satellite integration. So Samsung, Intel, all of them are there, Apple, and they're pushing for this and supporting. And it helps a lot because when you look at the satellite communication network, as any communication network end-to-end, the device part, the terminal part, is an integral part of the end-to-end network, and it is very important to consider the dual connectivity or the dual steer, the 5G and satellites, and it's happening. So that's probably the good news in the device segment in 3GPP at least. So it is there and has to be compliant with both. So 5G and satellite access. But the thing is that when you look, the disadvantage in the story is that the access network from VSAT perspective is an ETSI standard, the DVB, and it is not brought to 3GPP. 3GPP built on 5G NR and didn't really consider the ETSI standard. So that's where the satellite industry is adapting itself to the telco industry than the other way around.
Right, I got one more question because we only got two. So there's so many questions. It's great, but I think we'll have to take other questions after the session if it's all right, because we won't have time to get to the. By the way, we do have one more panel in about 25 minutes, so save up questions for that if you haven't had your question answered now. We will try and get to that. Just before we close this, guys, let's look to the future. When we look at things that need to happen to take this to the next level, be that in technology, be it in the business model, or be it in regulation, I just want to hear, just briefly, really briefly from each of you, like what would be the one top thing you think the industry needs to prioritize to scale this up?
I'd say standardization. I'd say this is a joint movement towards an ecosystem build. Yes, there will be competition, but I see more of a cooperation in this. A whole lot of, and again, this all goes back to that mathematical question. Number of IoT devices going up, 40 billion you pointed out. Number of people getting connected, although it's not at the same pace, but at the end devices are going up, the needs are going up. So that puts a huge pressure on the operator segment, and when I say operator, the MNOs and the satellite operators, in terms of reducing the cost per bit. So how are they going to do it if they do not collaborate? So I think open standards, reduction in capex by pushing more and more away from proprietary or bespoke hardware towards more and more, I would say, standardized COTS kind of hardware, and then open system interfaces, more interoperability, and the regulatory authorities or standard, the SDOs as we call them, 3GPPs and the rest of the world, including the brethren from the satellite side, so digital video broadcast or what we call as DVB, they all need to come together and drive this. That's how I look at it, to answer the question.
Yeah, I think generally speaking, you got to go back to the user experience. Like, look, you want to connect all your subscribers everywhere and connect everyone everywhere. How can you do that? Whether this is through satellites or terrestrial, and at the end of the day, can I use my existing phone to do that, or do I need to buy a new phone? Like, do I need to buy the latest $1,000 phone, or can I use my dollar phone type thing? So absolutely, I mean, it goes back to that question, going back to the user experience on how to achieve that.
Mina, you want to round us out?
I think I would go for standardization as well. It is really the enabler that would lower the complexity for all the users, the operators, the vendors, the integrators, the business models as well. So I think I'm biased, but yeah, standardization, definitely.
And just with the standardization point that you guys have made, I mean, how much of that has to be led by the operators versus satellite groups versus holdout satellite groups like Kuiper and Starlink coming to the table? Like, let's play the counterfactual. If they didn't come to the table on standardization, would that set the industry back overall? And do you need a kind of groundswell of everybody there to make, just like in mobile technology, everybody operating off the same standards?
I think that has a part to play in it, right? So we did see the rise of LEOs from these two big operators, right? And many a times I have heard this two different school of thoughts. One is, like the gentleman here was pointing out, vertically integrated versus I am completely disaggregated, right? Yes, so there is a question of who's going to come and aggregate my disaggregated stuff. But these are the two different school of thoughts which are actively pursued today. And somewhere I think that the second school, which is disaggregation, came because there was this rise of this vertically integrated LEO constellation, coupled with the fact that 5G came into our lives pretty much at the same time. So answer your question, I think everybody is responsible. It is not just the operator ecosystem, it is the vendor ecosystem, it is the standard bodies, it is the device chip makers. Everybody needs to drive towards that to make sure that the cost gets, I would say, risked out or amortized across the whole ecosystem instead of one person carrying the burden, because that's when you start delivering value to the end user, be it a consumer like you and me or an enterprise.
Yeah, so I think it's both, like satellites operators and mobile network operators. The only way to solve this is having both in the same room and solving it. So, and we're seeing a lot of this already in the industry, which is very encouraging.
Last word to you, Amina.
I think 2GPP won't stop. The fact that Starlink or any other player doesn't come to the discussion, they will have their own. They will still be vertically integrated and vendor specific, but still it will cover the use cases that the users have asked for. The other thing I wanted to say is that who's leading? I think you said that. Who's leading? Definitely today, the telcos are leading the standardization. Definitely. The only exception is Diffie. That's the only exception. But we're learning. We're looking at what the Cloud Run has done and trying to adopt this in the satellite industry. Maybe the ETSI standards can decide of creating a group of standardization group or industry specification group led by satellite players, and to go from DVB, or at least try to marry DVB and 5G NR, and this is not happening today.
Well, we could go on all day, but alas, we haven't got all day, and it's a great subject. We do have another panel coming up in about 20 minutes, but guys, thank you so much. That was a really good discussion, and it's given us a lot to think about. And thank you guys in the audience for the questions. Stay right there. We've got more for you, and if questions weren't answered, hopefully some of these panelists will be able to take them offline. But please join me in giving them a round of applause.
All right, good morning, everyone. And glad to be here. I just joined Globalstar, but have a long history with Globalstar because it was developed at Qualcomm, where I used to be the chairman and CEO. And actually on November 1st is going to be 25 years since the first over-the-satellite constellation call between actually my father and Bernard Schwartz of Loral. So pretty historic. The constellation's been around a while. And what I wanted to talk to you about today is not just the satellite, but also the convergence between the satellite and the terrestrial networks. So this combination of satellite and terrestrial, we're leveraging cellular technologies on both sides of it with NB-IoT. Okay, so Globalstar, I think, does everybody know Globalstar? Please? Does anybody not know Globalstar? Okay, good. So you know all this stuff, but I would just say the one new thing that we brought in with the acquisition of the IP or the licensing of the IP from my startup XCOM Labs is a terrestrial network, and we'll be talking about that tomorrow, so I'm not going to go into grievous detail about that here, but it's revolutionary new technology that gives kind of 5 to 10x improvements in spectral efficiency in a given area. So the business of Globalstar right now, it's really focused on kind of 4 areas. Whoop. I actually did mess this up. Forward. Definitely not working. There we go. Should I just tell you guys to advance, or is it working? I have to push it harder? So I did mess it up. I said, I got this. All right, anyways, so we have wholesale satellite capacity, which I think many people know, our partner there. This terrestrial network that I'm talking about, was just talking about in terms of the technology that we have, and we have terrestrial spectrum, band 53. We have a commercial IoT business, then we have the traditional legacy business, spot and rescue business. And the company's been around for, okay, it's not me pushing hard. Yeah, the company's been around for quite some time running a LEO network. So we've been running a LEO network for decades now. And obviously with the partnership that we have, we've been saving lives with the existing products, but now we've expanded to a much larger base of devices. So, making connections and saving lives is really part of the mission of the company. That's a new slide. Okay, so the XCOM team, a bunch of us came from Qualcomm to start this, and we built this wireless technology that basically does spatial processing. So at Qualcomm, we did a lot of new generations of wireless technology, 30 years of wireless technology development together, and always trying to improve spectral efficiency. And this is a new technique for that, where we use joint processing to improve the spectral efficiency of the network. And we use Open RAN as an architecture to build our technology on top of. So as opposed to most people who thought of Open RAN as a way to break into the telecom infrastructure business, we looked at it as an innovation platform and built our technology on top of that, and then got the rest of the network from other people. Next slide. Okay, so this is the global footprint of Globalstar. So obviously around the world we have gateways, we have offices, and with the addition of the resources from XCOM Labs, we now have in San Diego and in Bangalore, India. So you can see it's a global footprint, and the LEO constellation covers pretty much most of the Earth. So it's very, it's a full system. There have been some comments recently in the media that misunderstood the coverage of the Globalstar system. So it is not the fact. Some LEO systems that don't have a full constellation, the satellites will pass over every so often. This one has pretty much continuous coverage. Next slide. Okay, so the system, the interesting things about the system It's got a lot of spectrum. So we have S-band, L-band, and C-band spectrum that's licensed for use. But the super interesting thing is that it's a bent pipe. So it's basically a repeater in orbit. What that means is that when we want to change technologies, we don't have to launch new satellites to change technologies. We change it on the ground, and that's allowed us to upgrade the technology as time goes on, unlike some of the competition still using fairly old school technology. We are in the process, of course, of building new satellites or designing and building new satellites. That's to replenish the existing constellation. Some of those satellites have been up there for a little while, so it is time for them to get replenished, and we're working with MDA to do that right now. And obviously, as a LEO system, it's got low latency. It's not going GEO. And the other nice thing for IoT is because satellites are moving, if you have blocking from whatever your IoT application is, in the case of a GEO, you don't have that case with LEO. You'll get a chance to make the connection as the satellites pass overhead. So it's definitely a benefit for the technology. So anyway, so we have a bunch of different spectrum. Band 53 is the terrestrial spectrum. So we have spectrum that's on the ground. So in addition to the spectrum that we have over the air, we have the ability to use the spectrum on the ground. And so it's been standardized by 3GPP, and we have, actually I think the next slide will say how many countries. So it's 11 countries around the world. No? So these slides are a touch mixed up from the ones that I have. Anyways, so it's band 53. It's 11.5 megahertz that's available on the ground, and that's the part that we are using with the technology that we license from XCOM. So we take that 11.5 megahertz, which is generally a smaller chunk of spectrum, and now we multiply it by as much as 5 to 10x to get much more throughput through the same system. Next slide. So yeah, so like I said, the terrestrial licenses, we've actually gone out, done a lot of work to get the rights to use the spectrum on the ground, the S-band spectrum on the ground. 11 different countries, 850 million people. So it's really a nice thing, because if you're looking for an IoT solution and you want to have the combination, this convergence between the network on the ground and the satellite, on the ground we have a large number of countries where we can do that in already, and so you don't have to cobble together. If you're looking for something where you have both access to both technologies, you don't have to cobble it together around the world. Next slide. Here's your mine next to the train. Next one. Okay, so here you're on satellite or public 5G. Next one, you go to the port, you're on the private network, which we're doing already, as I said. Now you go into the factory. There, in terms of automation, we're already doing things for automation. Then you go to the truck. So there you'd be on either satellite if you're in out of coverage, or you'd be on the public 5G. And obviously we have a lot of experience in that from the old days of Omnitrax at Qualcomm. Then you're going to go to the warehouse, which will be public 5G and satellite into an enterprise private network where you're doing warehouse automation. And so we're working on all of these technologies and in all of these markets right now. We have systems that are actually out in the field and built out. Okay, so to kind of close the discussion, essentially, okay, next. So if you think about it, now Globalstar, with the addition of the XCOM technology and the RAN that XCOM's building, we actually have a complete end-to-end. So we can go the entire life cycle, as I said, from raw materials to finished goods, and in a lot of other applications, as I talked about, the other markets, in terms of livestock, in terms of oil and gas, all these different markets, we have the opportunity to cover those because we have the existing LEO system. The constellation is up there, it's stable, it's funded, we're replenishing the satellite system. We have the spectrum on the ground, so we have the opportunity to use the spectrum in, as I said, 11 countries. It's highly scalable technology, whether you're talking about growing to larger networks or you're talking about growing an opportunity globally. we have that opportunity to do all of those. And then, like I said, whether it's satellite or on the ground, we have that coverage for the system. So Globalstar is really in an interesting place. It's one of the reasons why I decided to join the company, because it's a company that's a good size. It's able to move very quickly in terms of its ability to adapt to new opportunities, and it's, I ran Qualcomm, which is a very large company, sometimes hard to move a big company. I've ran a startup in XCOM Labs. You spend a lot of your time doing fundraising, and Globalstar's in this really nice Goldilocks spot of a company that's built, it's been around for decades, it's got its process, it's got, it's really set up to scale from the resources that we have. And like I said, they've done a great job getting the system up and going, getting it funded, and operating it for many years. So despite not having the right slides, so you guys got a preview, you only have to come to the latter half of my talk tomorrow. But anyways, thanks very much for listening to me.
Paul, thank you very much for that presentation and for sticking with the slides through us. So lots to go on there. We are going to move to our final panel. Just want to check that we've got the mics set up for that. Abby, if you are around, are we good to go? Okay. Okay, well, we are going to go to lessons from the field and talk about the deployment examples, some of which we talked about before and some of which Paul was referencing. So we are going to have Brian Helmick from Roden Schwartz joining myself, as well as Parth Trivedi, who heads up Skylo, and then James King from SES Systems. So if you guys could get the mics from Abby, and if you've got them, then just come on up. Oh yeah, there we are.
We wanted to go right.
Yeah, I didn't see it. Thanks.
Hello?
Thanks. Yeah, you guys sit over here, and then I'll take this one. Okay. Right, thanks. All right. So with these mics, you just kind of speak close and don't hold too close. All right. So we talked about up front some of the strategic rationale. We've talked about where the sector is going. We've talked about some of the use cases. I think, and I know people in the audience still have a number of questions that we haven't been able to get to, but what we want to do with this panel is, and we've got about 35 minutes, 40 minutes, is go into lessons from the field and really bring kind of practical examples from your experience to speak to some of the topics that we've been talking about today. Be that technical innovation, be that some of the kind of learnings you can speak to from partnerships, and customer feedback if you can cite any of that. So maybe if we can start on the performance and sort of technical side without getting technical, if you know what I mean. But we've talked about some of the constellation capacity increases, the increased speeds, the lower latencies. Parth, maybe I can start with you on this. How can you speak to how that is playing out in practice, whether we are realizing increased speeds from satellite constellations, and if so, what difference is that having to people, or should that have to people using the connectivity?
Thank you, Matt. First of all, can everyone hear me? All right, great. All right, thanks, Tim. So I do think that there are quantum leaps that are happening in the satellite sector, but we have to think about what spectrum bands and what constellations we're talking about and what services you're referring to. If you're talking about broadband satellites, absolutely, you're now able to use a OneWeb or a Starlink system and get 50, 100 megabit speeds anywhere in the world. That's an incredible capability that we didn't have 5 years ago. If you're talking about the direct-to-device or NTN landscape, I think we have to set very realistic expectations on what is possible today with the cell phone that is in your pocket and with the constellations that are in space, right? And those expectations, I feel, are a bit skewed right now. But realistically, everything that you can do, and I mean, Paul was talking about this, everything you can do with NB IoT terrestrially, you can do over NTN with satellite today.
James, you want to go next on this one?
Yes, thank you. Can you hear me okay? So one thing we haven't talked about much is MEO. And 10 years ago, O3b launched the first MEO satellite. In a few months, we're about to announce the new service, the new next generation of that, Empower. The types of speeds that we're seeing so far with current MEO, it's been about 500 megs to 500 megs forward to return. And it's been very successful. It's actually made, we think, a very big difference around the world. And the original name O3b meant other 3 billion. The name applies to 3 billion of the people in the world that are underconnected, and basically places like American Samoa, Chad, Brazil, all over the place. And the types of speeds we're seeing coming up in the next few months are going to be in the multiple gigabits forward and return. This is to a single site, and so it's nothing like anything we've seen in satellite before, with predictably low latency in terms of latency. So that's kind of, I think, probably the biggest technical innovation I'm close to in a satellite world.
I've got a follow-up question for you on that, but first I just want to come around. Brian, maybe you want to weigh in on this as well.
Sure. Yeah, right now what we see is IoT NTN is what's actually happening right now, being deployed today. And with that, there's use cases, really important use cases in the market. You've got 70% of the world is covered in ocean. At any given time, there's 2 million people on the water. And there's 30% of the world's covered in land. 80% of that land has terrestrial network coverage. That leaves 20% of people with nothing. And then you've also got only 40% of the area in the landmass is actually covered with terrestrial networks. In addition to that, you've got people in the air, 500,000 people in the air at any given time. Most of the people that are out of coverage don't need, 10 meg, 10 gig. You're okay with 10 kilobits a second or 100 kilobits a second of data. NBN10 seems to be the technology that's being deployed right now, and there's a big use case for it, and it's pretty exciting.
We'll definitely get more into the IoT side because that, as we've talked about today, I think that's really one of the high growth areas where we're going to see satellite connectivity service. James, can I just come back? So you we have this question, and I think we referenced it in a previous panel of how can you get speeds up to sort of 4G or maybe even 5G-like speeds? Not VSAT broadband, but to a mobile handset. We did some modeling against a company that shall remain nameless a few years ago who was promising gigabit per second speeds from their space sites. And when you did the math, you could do that, but only 2 people could connect to the site at one point. And it spoke to the problem that actually the level of capacity in space wasn't there to deliver what was being advertised. Now we fast forward, that was 5 years ago. If you look at now, how, either from a MEO or a LEO posture, how can we look at what is still needed to happen technically to bring speeds up and latencies down, and how feasible is that?
So latency obviously is a factor, it can be a factor of orbit. Obviously in the LEO orbit you have potentially much lower latency. In the MEO we find that it's about 150 milliseconds, but it's actually a very predictable latency because typically you can reach 2 endpoints with a single leap, and sometimes if you're in a longer network distance, the LEOs are having to do some ISLs or some backhaul terrestrial of some kind, and latency can be variable. The MEO service that SES is selling is basically focused on MNOs, telcos, very, very demanding customers. It's not a consumer offer, and we're designing it differently in order to fulfill the need. And the need that we see is that working with telcos, they can get a single beam of 500 megs forward and return today. With the new service, as I said, it'll be multiple gigabits potentially. They can get that to a single point, and then that carrier uses their terrestrial network to spread that bandwidth out across the Earth, and that's basically how it works.
Parth, I want to come back to you. You have an engineering background, I believe.
The wrong one, but yeah.
Bringing it to bear in a good way. Again, not getting too technical, but talk about how you approach Skylo's value prop with your partners. And how does that take us through that conversation when an operator is thinking, okay, we want to partner, we want to increase our coverage. What types of things are they asking you to deliver within that framework? And not getting specific into commercial agreements, but at a higher level, how do you go through that value prop now?
All right. So there's 3 key ingredients that you need to deliver an NTN service to your handset or to any cellular device for that matter. The first thing that you need is an ecosystem of chipsets that are compatible with the release 17 of the 3GPP standards. That took several years to come about, and it was ratified in March of last year. And frankly, we worked with Qualcomm for a number of years. We worked with MediaTek and Sony for a number of years to deliver this capability directly inside those chipsets. The second key ingredient is satellite partners who have MSS spectrum available, as well as compatible satellites on which you can deploy that capability for NTN. And the third key ingredient is the entire software-defined network infrastructure, including the RAN, the core, the OSS system, the BSS system, the SIM management and provisioning system, the entire supply chain for any telecom business that's needed to enable NTN. And all of this, again, has to be part of Release 17 of the 3GPP. In fact, from our perspective, there are some additional things that we have to do to make all of this work in an economically prudent way with a consumer experience that doesn't require you to take your phone and point it in odd directions in the sky. And that's what we did. We're a global service operator that uses a software-defined network infrastructure layer in partnership with the existing spectrum holders and the existing satellite operators for MSS.
Brian, I know you sit in a different part of the value chain, but can you, same question, sort of how do you approach the value prop question now, and how do you articulate that for your company?
Yeah, we Rohde and Schwartz, we make test equipment. So we deal with the SATCOM industry, aerospace industry. We deal with the 3GPP-based commercial wireless industry, chipset manufacturers, the operators, third-party labs, UE manufacturers, all of them. And we believe that there is room for non-3GPP and 3GPP-based NTN because each has its own advantages. Like, for example, the speeds. So if you want those like VSAT speeds, the megabits, multiple megabits, then you need to have frequencies over 10 gigahertz. You need to have phased arrays. That's not part of the 3GPP offering right now in Release 17. That's in Release 18 and beyond. But there's advantages of both. The non-3GPP, it's kind of like a Formula One race car. You can come up with a great idea, get it out there, get it deployed, win the race, right? With 3GPP, it's more like a freight train. So you've got a whole bunch of companies all working together, going to meetings, defining a spec. It might not be the fastest, but it sure is hard to get it off that track. And right now, it's a really important time with Release 17. We're seeing deployments of NBNTN now in Release 17, and then NRNTN, so sub 6 gigahertz, L and S band. Okay, those aren't crazy speeds of 50 or 100 meg, but still 1 to 10 meg. You could still have a potential 5G service, voice calls, and direction finding, Google Maps in the middle of nowhere, which is quite important. And we kind of deal with both sides. And what's really exciting for us on the 3GPP side for NTN is testing, because testing is important. If you have a proprietary technology, you don't get the ecosystem of test equipment. So us and our competitors building solutions. You also don't have standards bodies creating conformance test cases that all the test equipment suppliers can design to. And testing is critical. You don't want to launch satellites into space without testing them first or testing them against the UEs. And if you have test equipment for RF, protocol exchange, radio resource management, which is the mobility between cells when a device is going between cells in one satellite or between satellites, or even from NTN to terrestrial coverage. That's very complicated. There's test cases that get defined for testing that before you deploy. So, yeah, sorry for the long-winded answer.
No, that's, I'll come to the audience in a sec, but James, just to round out this portion of the discussion, at SES and from your perch, from a performance level, what do you think, what one or two things are most important to improve satellite performance in the next 5 years, either from a MEO or LEO perspective?
So speaking from a MEO perspective, which I will, and SES operates in multiple orbits. We operate in GEO as well as MEO. Obviously, what we think is important and what our customers, our telcos, MNOs are looking for are guarantees for speed. So a guarantee with an SLA for the high speeds that we're talking about, as well as performance around the latency. So guarantees of a consistently low latency, and then also the service, obviously, having a network operations center that is there and responsive to customer needs. We also think flexibility is important, and so again, I'm talking about connecting to MNOs and telcos. We're basically MEF compliant. We have ONAP standards that we comply to, and we're connecting back on their backbone, their core. So frequently where you'll see that is maybe in a disaster response where cell towers are down, they need to restore many sites altogether. We're providing that cell backhaul as an example, or as we've seen in other parts of the world where you're providing service to an island nation that didn't have communications before.
Right, I'm going to take a break in my questioning line to put it out to the audience here again. Are there any questions you guys would like to ask so far? Yes, sir. So can you just repeat that one more time? Yeah, just hold on a sec, Parth. Okay, so the question is to Parth here around Skylo's progress of their work with different chipset and device makers, and how that what that means for commercial deployment. Parth, do you want to take that?
Yeah, absolutely. Thank you for the question. So we partnered with MediaTek a couple of years ago to commercialize NB-NTN, and we successfully certified their chips onto our network. We, of course, did this in partnership with the incumbent satellite operators across different geographies. And we then partnered with a company called Bullet out of the UK, which deployed smartphones as well as wearables under the Motorola brand, as well as the CAT brand. And in fact, you can go to REI and pick one up right now. You can go to Costco, 3,000 AT&T retail stores. And so NTN is here. I think the exciting thing is you can go buy one right now and test it out. And the way we think about it is, how do we eliminate changes in user behavior for folks to adopt and access the service? So we spent almost a year really perfecting the mechanism for delivering the service in a way that didn't require you to change your sort of position when you're texting, right? You may be walking outside, you may be hiking, you may be inside your car. You should still be able to experience NTN without any unnatural act. I mean, that takes a lot of engineering behind the scenes to make happen. And obviously, we chose the right protocol to do it. We had a lot of IP that goes on behind the scenes to make it work. But I think the most important thing is that phone does not emit any higher output power than cellular. That phone emits 23 dBm max output power, which is the same as cellular. I think that's a key for eliminating a change in user behavior, because you don't got to charge the thing any more than you do when you're using it over a cell network. The switching that happens between a cellular network and a satellite network, that's got to be seamless. Again, we spent months perfecting that capability with our IP. There's a number of things that we did. Again, I can go on, but the experience should be just like texting over a cell network, and that's what we've done.
Any other question? Yeah, yes, sir. Yeah. Okay, so the question here is around spectrum usage, and for NTN, are we limited to S and L band? Yeah, I was going to come to this part of the discussion, but who wants to kick off? Do you want to go into that, Brian? Or no?
Yeah, right now it's S and L band. It's what, 255 and 256, and in the future they've already defined bands up above 10 gigahertz FR2 bands for basically VSAT devices. But none of those are deployed yet, and they're still under discussion. There will be more bands than just 255, 256 deployed. They were still in the early days of NTN, so.
Yeah, so we're operating in KA today, KA and KU as well, yeah.
I'll just say that, look, your phone supports up to, sub 6 gigahertz is what's inside your phone. And so you've got to think about what spectrum bands are able to be unlocked in the software-defined front ends of the chipsets and the RF front ends of the radios that are in your phones. Because you don't want to add it, as a phone maker, the last thing you want to do is add extra hardware in your device. So bands 255 and 256 L and S correspondingly are part of the 3GPP spec, but frankly, that's not a constraint, right? Clearly, Apple has launched something outside of that spec in bands that Globalstar owns. That's not part of that, either of those two definitions.
I'll come back to you guys in a minute, but I just want to sort of pivot the discussion to the enterprise angle here. We talked up front about the IoT aspect of this discussion, and I think that's there's consensus that there's a lot of interesting things happening there. What sectors do you think are most likely to be using satellite that either aren't using it now or are going to sort of grow in their usage of it? And can you speak to any examples in that? Do you guys want to?
I mean, the most exciting use case right now for the NBNTN part is the texting and the emergency SOS out of coverage, but there's the entire NB-IoT ecosystem that would love to have IoT services out of coverage. I mean, smart asset tracking and smart agriculture. I mean, cows are expensive, so track the cows wherever they go. I mean, these type of things on land, in the air, on the ocean, all the maritime stuff, so super critical. Then if we move into actual NRNTN, I mean, who wouldn't want to have ubiquitous coverage for your smartphone in your pocket anywhere you go, no matter what? Maybe you can't do a FaceTime call or some YouTube download, but you could still do your normal voice services and things. I don't think you need a lot more use cases than what's right in front of us, but I'm guessing that you probably have some other ideas.
Do you want to go next, Barth?
Sure. So
introduced.
I think the really exciting thing is we've actually connected smart watches directly over satellite with zero hardware modification. Think about that. That's a -6 dBi antenna inside your smartwatch, right? And that means that form factor is no longer a constraint. I can now put NBNTN on a printed label that goes on top of a container. I can put it inside a pet tracker. I can put it inside a cattle tracker. That was built for cellular. None of these devices need to be built for satellite. I mean, your banner, you had a VSAT terminal in the banner for this session. I almost wish you had a cellular device like an iPhone. I mean, that's more representative of NTN than a VSAT terminal, because the whole idea is eliminating proprietary hardware. So I was just in Jakarta last week. There's 2 million fishing vessels over there, less than 20 meters in size, that have never had any form of connectivity. These guys get lost at sea every day. It's absurd. They lose their lives to storms, hurricanes, things that are preventable, meaning you can call for help. You can call the Coast Guard now that you have connectivity at sea. I think maritime is going to be a massive application for NTN. Think about the automotive segment. We're talking about satellite SOS on your phone. What about your car? Every time you think about automotive situations where you're driving and you need access to simply knowing where the electric vehicle charging stations are. I was in Utah, I didn't have any connectivity there. I wanted to know where the nearest charging station is. So you're going to find very pragmatic applications for NTN delivered across automotive, enterprise, IoT use cases such as maritime and mining, but also consumer, like wearables.
So quite a range. James, do you want to chime in on this one?
Yeah, just again talking at a different scale.
Yeah.
We operate on most of the cruise lines around the world, and folks that go on the cruise, they experience something that's like gaming at home. It's just amazing, and so it doesn't work well on a small 20-foot fishing boat or on my sailboat for that matter. Yeah. But if you have a congregation of people where you can take a gig or two of bandwidth and spread it across that user base, it makes a lot of sense. We're finding navies where you have a lot of men deployed or men and women deployed on ships overseas. They connect back to home, they do videos, their kids' birthday parties, those kinds of things. Makes a real big difference.
I think, there's clarity that there's a lot of applicability across different industries. But Parth, the example you raised in Indonesia is an interesting one, because on the one hand you have a huge potential market for this technology. On the other, you have the reality that it's not being serviced yet. And how do you bridge that gap? Is that a sales channel effort? Is that a cost reduction effort? Is that a kind of digital education? How should we think about closing that gap?
Tim, it really depends what sector you're talking about. If you're talking about the consumer sector, the go-to-market at the moment looks very different than the enterprise sector. Which one do you want me to talk about?
I'm talking about the enterprise sector for now.
All right, so in the enterprise IoT sector, large part of the market is governed by the module business. So whether it's Quectel, Murata, Telit, Fibocom, these are the companies that developers go to when they're building cellular tracking solutions, or almost all the module makers that I mentioned. And what that means is, if you are developing cellular devices today for any of those use cases we just spoke about, you have access to this capability inbuilt into the latest modules you're buying, right? Then the question becomes, how do you deliver this service on a recurring revenue basis to the customers who need it, the end customers who need it? What we're finding is that in each country, and clearly we can't build a sales team in every country to go out and do this, and especially for IoT where there's so many different segments, we'd be boiling the ocean. So what we decided to do was we partnered with the carriers. Deutsche Telekom last week launched their early adopter program powered by Skylo, which allows IoT companies in Germany and in Europe to leverage NTN in a very native way that they're used to. And we'll find that playing out in other countries as well, where carriers are going to take the lead in converging NTN with their cellular enterprise IoT offering. Either as an insurance mechanism that, hey, for X dollars or cents, you just have access to this capability on every single compatible device, or as a premium add-on that, hey, if you want a dedicated sort of solution with a large number of messages or sensor data built in, then perhaps there's a premium plan that you subscribe to with both.
Yeah. Brian, I wanted to come back on some of the testing points you were making earlier, and we've been given tours of some providers and some of the engineering that's going into this, using digital twins, using AI, using other things to help plan satellite constellations so that those are optimized pre-launch. Can you talk us through some of the advances there that are happening and where you think that space goes, so that operators have more assurance over the types of constellations that are going up in the sky?
Sure. NTN, being that we're talking about comm over satellites, there's a lot of challenges In particular, and the good thing is in 3GPP, these challenges are met by a standards organization. And even if they're not totally met in one release, they'll be met in the next one. One of the big issues, of course, is time synchronization. So when you have these very large distances, you need to calculate time in advance, which can be crazy complicated, but luckily there's smarter people than me that work on this stuff, and you can test this in the lab. RF powers can be extremely low, which could be a big problem. Frequency synchronization is also an issue with LEO and MEO because of the speed of these satellites. You get this Doppler effect. But you could fix that with pre-compensation. You can also test that in the lab. This stuff is tested with conformance tests. There's issues with weather effects, atmospheric effects. These are things that are real-time, changing all the time, but also the devices and the networks, they report with measurement reports, they report what they see. So this stuff could be dealt with real time. And again, in the lab, you can test and make sure that this is going to work before deploying.
Let me go back to the audience for now. Are there any other questions people have at the moment before we carry on? Oh, good. Yep, please.
How do you see the 3GPP ecosystem working on NTN versus large successful enterprises like Starlink, and then upcoming AST Mobile, Link, and others? Where do you see this race going? Will be more separate races, or will be ultimately onwards to a single standard base?
Yeah. So the question is around the risk of standards becoming fragmented if different companies don't all coalesce around 3GPP. Actually, it was a question asked in the previous panel as well, but as we've got fresh faces up here, I'll give you guys the chance. So who wants to kick off on this? I mean, do we think there's a risk of standards fragmentation? And if so, how does that get rectified?
I could start. I mean, satellite communications is not the first technology to have this issue. And what you always find is there's always room for innovation outside of 3GPP. You know, like I mentioned before, 3GPP is truly like a freight train. It's not the fastest, but it's really great because you know where you're going. It's standardized. Everybody can develop hardware and software to a spec. But then that is restrictive as well. You do need room for other technologies that are not 3GPP to make these really big quantum leaps. Okay, maybe those devices and satellites and that technology is not the cheapest, but cruise ships, if you're in the cruise ship and you want high-speed internet for gaming, you're probably not caring about how much money you're spending. But if you just want to send a text message from your cell phone, you know, on a mountain, you probably do. So I think there's definitely room for both, and we see it now, dealing with aerospace and aerospace defense and non-3GPP, NTN. Everybody is healthy, I would say, and it's going to continue like that.
James, do you want to chime in on this?
Well, just basically, you made a good point about the texting and all. We're talking about different speeds here. We're talking about, you know, performance like you expect to see from 5G, and that's the experience we're delivering. It's delivering it through telcos, etc. And we are following standards that are applicable to those speeds. We're not going direct to handsets, so I don't have anything to say about the handset piece.
Perth?
My prediction is that everybody is going to converge to the standard, and here's why. Right, the standard currently offers a dramatic improvement over a brute force approach to NTN. Right, you can trick the phone all you want into believing that it's near a mobile base station, but the reality is that, one, spectrum is a bottleneck. You need to maximize the number of devices that are able to use that spectrum. The amount of power that's available to you on your phone is a bottleneck and a constraint, and you've got to make sure that you're using that resource judiciously. And frankly, the amount of benefit that, for instance, NB-NTN offers as a protocol, it was designed for low power applications over long distances. It is perfect for this use case. So what we're finding is that we're able to deploy a network using of course, NB-IoT uses 200 kilohertz of spectrum. If you try doing that using an LTE waveform over 1.4 megahertz of spectrum or over NR 5 megahertz of spectrum, you're spreading your limited RF energy over a much wider bandwidth. That makes it exponentially harder for you to close the link successfully and offer a reliable customer experience, right? The second thing is all of the chipset makers are now doing this. We work with Qualcomm, we work with MediaTek, we work with Sony and a bunch of others. Everyone is conforming to the standards now. The third thing that I'll add is what China is doing. Maybe not everyone's aware, but China's got the Tiantong 1 constellation, and all their phone makers are also integrating into offshoots of the 3GPP standards, whether it's Huawei or ZTE or Xiaomi and others. What we're going to find is that there is going to be a second, call it a parallel NTN that will come out of China, but that will be based on an offshoot of the 3GPP standards. You're going to find some default OEM behaviors play out here over the next couple of years. It's not obvious now, but it will be.
I mean, to a certain extent, we've got, this story isn't new. I mean, we had this with CDMA and telecoms 15 years ago. We've had it with WiMAX way back when which didn't work. But I think the lesson there is, and you might be vindicated, Parthan, that history also says that fragmentation gets closed over time. But just to flip that back, I mean, why do you think some groups have not come to 3GPP so far? What's the rationale for Kuiper or Starlink, to name two, to have held out? Any thoughts?
Yeah, a couple. One, Kuiper is just a completely different spectrum regime, right? It's not compatible with your smartphone. And same with Starlink today. Gen 1, not compatible with your smartphone, right? That's why you need a massive Starlink dish with 300 watts VAC to power the equipment, right? When you're talking about sub 6 gigahertz, I think conformance to the standards is closely tied to access to bands 255 and bands 256. If you ain't got access to those two spectrum bands or some variant thereof, your incentive to participate in the standards is probably limited to none. But I think that over time, we're talking about cellular frequencies that can be unlocked in the RF front ends. So it's not inconceivable that all of these companies will fall back or converge to the standard, but that's not where they are today. Starlink, for instance, other companies that are trying to do direct-to-device don't have access to the MSS spectrum that companies like Viasat and Inmarsat have access to.
Yeah, the AST, it's LTE. The device doesn't know that it's connected to the network, which is really innovative and exciting. So again, benefit, got it out, good idea. But the disadvantage would be that the satellites, the infrastructure is still proprietary, right? And ultimately, I mean, you're probably right. As time goes on, things get moved to the standards. NB-NTN, NR-NTN, those are relatively new. They're release 17. Those will be the first ones that most people move to a 3GPP standard. But the reason why not everything can move is because you've got release 18 with the VSAT stuff, and that's not ready. There's no chipsets or infrastructure for that yet. And like I said, it takes some time for 3GPP to happen.
I mean, it's interesting you bring that up, because a lot of the technological innovation we've seen of late has been at the chipset and the device layer of the value chain. Qualcomm, MediaTek, you talk about Bullet. When you look at whether you're talking about direct-to-device or other variants of satellite technology, to realize the premise where, let's say, hundreds of millions of more people than today have access to this technology, or maybe even billions, how long is that from now? I mean, no one can be sure of it, but what are we talking? 2 years, 10 years, 5 years? Can you give us an order of magnitude?
So we have a technology training center at Rohde & Schwartz, and technology manager for NTN, and I'm looking through his predictions. He's saying 10 to 20% of commercial wireless devices will have some sort of NTN coverage in the next 2 years. Within 5 years, something like 40%, and then within 10 years, 90%. So that's going to take a lot of work. I mean, right now we have, today, if we ignore the NTN part, we had more of an interworking between satellites and terrestrial networks, where a device would use measurements of the satellites to help it and the network calculate location. With NRNTN, we've got more of a integration. So you get 5G from satellites and terrestrial. In the future, as time goes on with 5G Advanced Pro, and then 6G, we get this so-called unified network or 3D network, which then it's not just satellites anymore, it's also UAVs and these stratoplanes working with terrestrial networks and satellites. That's where you can get the 90% coverage. It might take 10 years, but it will come.
Yeah, I would say that it's actually happening now. You think about the volume of iPhones that are being shipped out. You know, Motorola's already put this in their smartphones. It's public now. I mean, you know, Android is integrating this as well inside their OS natively. So what you're going to find is that most smartphones in the next year to 18 months, they're going to carry this new mode of communication, which is satellite. Frankly, you may not even know that you're using it when you do. And to do that successfully at scale, again, we need to create an ecosystem with good partnerships and collaborations like the one we've had with Rode and Schwartz. We announced our partnership yesterday, where we are accelerating device acceptance and testing and certification onto our network through OEMs who want to use our service, using the existing call boxes and test equipment setups that they already have. And that's a key enabler for getting hundreds of millions of devices out there.
And just clarify for the audience here and our remote viewers, when you're talking about iPhones being shipped out and Android having this, you know, kind of be a native feature for it, does that require people to get a new handset, or can this happen with existing devices?
It is theoretically possible to do it with existing devices with the right firmware running in the 5G modem SoC. But obviously the incentive of the industry is to sell new devices. That's just the reality of the situation, right? So you are going to find NTN in new devices going forward. And sure, you can, and we have, by the way, enabled asset trackers, cellular asset trackers for demos and tests. We have done that, updated it with firmware from release 17 with our chipset partners, and successfully enabled that over the air. We've done it with Flextronics publicly. You can do it, but I think what you're going to find is that this experience has to be curated at the moment. So people are not aware under what circumstances they get to use it. People are going to try using this from their garage. It's not going to work. So it's got to be a bit of a curated experience for that reason.
James, do you want to weigh in on this question? In terms of like the timeline that we would see a kind of larger addressable base, or no?
So from my perspective, a lot of it has to do with social inclusion measures by governments around the world. And we're seeing that more and more are accepting satellite as a way to communicate. And projects, for example, in Honduras right now to communicate all their schools, they were badly hit by COVID. And kids basically weren't able to go to school at all. And so they're a couple of years behind now. So I see an increase in funding of those projects that will increase the broadband acceptance across the world. But I hope that comes true, that it's soon. I know maybe 10 years, I think that's optimistic, but you know, that would be good.
Yeah. Questions from the audience before we go on? Yes, sir. So the question, just to be so everybody knows, is around smartwatches receiving satellite connectivity and how that happens. Parth, you brought up this example before, so over to you.
Right. So how we make all this work is using the NB-NTN specification. we are able to squeeze all of the RF power inside your cellular device into a 3.75 kilohertz uplink carrier, subcarrier. And that allows us to really close the link because it's a capillary tube going up. And by the way, we use geostationary satellites at the moment. So it's even a longer distance that you have to bridge. But these are not your same sort of power class as LEO satellites. They're incredibly more powerful than LEO satellites today. They have giant mesh reflectors the size of a parking lot in space. These are 18 kilowatt class satellites, extremely powerful. On top of that, we have developed IP in the back end in software that allows us to do certain error correction as well as modulation and coding schemes that give us that advantage, that punching power that is needed in the link budget to close the link. By the way, believe it or not, in that smartwatch example that I mentioned, the constraint is actually not in the uplink, it's in the downlink. Because the antenna of the watch is what it is. I can't make it bigger, right? And I have extremely high receive sensitivity in the sky. So it's actually constrained on the downlink, not the uplink.
Any other questions from the audience before we go on? Okay. We've got a few more minutes, guys, but when we talk about, so let's talk about partnerships. Everybody, I know you all operate in different parts of the industry, but at a generalized level, I think a lot of the questions we get from companies who read our reports or through forum like these are, how do you approach partnerships when you're bringing different technologies together? Can you speak to examples from your own companies about how to think about bringing technologies together, how you harmonize those, and how you think about operating together as a partnership over a period of time, and what a startup might want to think about, or other companies entering this space? Do you want to go, Parth, or kick off?
Oh, yep. Yeah, as a test equipment supplier, we definitely really appreciate partnering with operators because conformance can only take you so far. 3GPP, there's a RAN 4 group, they define all the measurements and KPIs. There's a RAN 5 group, they define conformance tests. But these are all agnostic to the operator. It doesn't matter if it's an operator in the US, in China, it doesn't matter. They're agnostic. They're meant to be agnostic. So with that, you end up needing to work closely with operators like Skylo for anything that might be specific to them. And we really appreciate it. We work together, and this all helps to push the technology forward, make the devices and the network ultimately work better. So,
and from that example, I mean, can you give an example of where you had a challenge that was, that had to be overcome in that, and be it a technical challenge or something else that needed to be worked on, and that ultimately was overcome?
Yeah, it won't be Skylo specific, but when LTE first came out, there was a problem with high power television transmitters down in 700 megahertz, and this, not just that frequency, but also the intermod products and stuff were falling right into the receiver frequency, which was really hurting receive sensitivity of devices. So these devices had to deploy filters and things to mitigate that problem. So you need to create test cases because the conformance specs, they won't think about high TV television transmitters in the US. Also, conformance doesn't really do a lot with data throughput. That's one area, like actually testing how much data performance a device is getting with the network. And there's negative testing. Conformance also typically checks to make sure that things are working. It doesn't check to see when bad things happen, how does a device or the network react. So those are all areas we create test cases. So, yeah.
Just going back to the partnership question, James, for you, I mean, be it a cruise ship operator or other clients you deal with, how can you speak to the sort of things to factor in when you're looking at a longer term partnership here?
Yeah, that's a great question. So we do work very closely with our partners around the world. SES, we don't do business directly with any end user at all. We don't go direct to consumer. We depend upon our partners to bring our services to the market. And our partners have the expertise in whatever business it is that they're in. We do have a government entity that obviously specializes in that, but in the commercial side, basically the telcos will know a market. And take an example like Papua New Guinea had no communications for a very long time. The local operator there, very entrepreneurial, and invested a good bit of money in building out this network. And it's had some setbacks, but it continues to advance. And we've got situations where, there used to be or it still is, I guess, a brain drain that occurs. The best minds of the world come to the United States for universities, and then they stay here. They don't go back to their other countries. We're seeing in cases like in Papua New Guinea where folks come here for university, they can go back to where their home is originally, and they have the internet connectivity that they would have in the U.S., and that allows them to earn a living as well as, or even better perhaps, than they could in the United States. And so it's fundamentally changing the economics in some of these countries, not to mention also like medical, education, and disaster response as well.
Parth, do you want to chime in on this one?
Yeah, for me, the biggest lesson learned in building strong partnerships here is eliminating changes in behavior, again, for our partners to work with us. What that means is when we're working with the supply chain, if you're a device maker, again, nothing different to do. If we're working with a carrier as our partner from a roaming perspective, they ask us, how are we going to integrate with your NTN? And my answer is exactly the same way you integrate with any other terrestrial network. And that's exactly the right formula needed to accelerate the adoption and scale of NTN, is when you don't have to do anything different to integrate with it. We broadcast our own PLMN, we issue our own IMSI range to the extent that you want to use that, or we can authenticate your SIMs onto our network. Just a small example of how we're eliminating speed breakers along the way to make it faster for folks to use NTN.
Yes, sir. So the question here is looking at, again, extending on the partnership question, but for Snapdragon and others, are they proprietary or working through other systems? Parth, did you want to clarify that?
Yeah, absolutely. I think Paul mentioned that Globalstar uses the IS-95 waveform. You can call that part of the broader GSM group, but it is not part of 3GPP Release 17.
Any final question? Yes, sir. Yeah. So yeah, this is kind of reprising the question we had earlier about, which I put to the panel, about how long it would be until we see mass market availability of this technology, and that's a sort of multifaceted answer. It will depend on how quickly individual chipset makers incorporate their devices into individual devices, when those are brought to market, and how quickly the handset replacement cycle takes its course. Could be 3 years, could be 5. I mean, we'll see, but those are the sort of influencing factors that will help to drive that. Yes, sir. One more. Yes, please. Yeah. So this question is, again, a variant of something we've talked about. It gets to the economics for a telco operator of offering satellite connectivity through some of the constellations, whether it MEO or LEO or GEO, that we've been talking about. I mean, maybe this leads us as good into the sort of the last question here, last two questions, guys. I mean, step out of your shoes and put yourself in the shoes of a telco operator here. When they go to market now, with the constellation volumes we're seeing ticking up like they are, how does that help them in terms of their own economics? Should they think about that mostly as a cost reduction story in terms of integrating satellite at a lower cost than it used to be possible? Or can they think about this as well as a sort of revenue upside, or both? You want to start, Parth?
Yeah, from my perspective, it's pure incremental gross margin to the operator with zero capex invested and, frankly, zero spectrum invested either, especially when they're working with us. And I think my argument is, if there was a business opportunity to set up a cell site would have come up, right? You would have had microwave or fiber backhaul, and a cell site would have come up if the pop density was high enough to justify a cell use case. Frankly, it's the same for Wi-Fi. If the density is high enough, like in an environment like this, you should use Wi-Fi. There's no need to use cellular. By that same logic, there will be environments where cellular just doesn't make economic sense. It doesn't make economic sense to put up a cell tower. And frankly, the Pareto optimal of the capabilities you're offering over NTN don't justify the means of setting up new infrastructure on the ground.
Either of you guys want to elaborate there? Or no? James?
Yeah, well, as a telco operator, one of the ways that you can use satellite is obviously to explore a new market. You can drop in a satellite. It takes a couple of days. You can test that market out. If it doesn't work out, yank the satellite out, and you're done. Another way to look at it is when disasters do happen and your network is wiped out, maybe your fiber's cut, it's a matter of churn. You've got to get your service restored quickly, or you're going to lose customers. Because if I'm on AT&T and Verizon's next door, and I'm up and they're down, they're going to be coming over to AT&T, so or vice versa. But so it's a matter of churn as well as just growth. And I think that's how I look at it. I think it's it's going to play a bigger role as time goes on.
Sorry, Brian, do you want to go?
Just, I don't know the specifics, but I do know that the insurance industry is very interested in NTN really becoming successful, because, life insurance policies, people won't collect as much if you have NTN services around the world. Government, you mentioned disaster relief. Terrestrial networks, they can go down during hurricanes and stuff, but there's no hurricanes in space. There's going to be some other pushes than just people spending money on a service for their iPhone. It's also governments and insurance. But I totally agree with you. I think, I would pay an extra $5 a month to be able to send text messages wherever I am. Going backpacking or fishing in Alaska, and I don't have any service, and I need to send some text messages.
Mountaineering or skiing, whatever.
Right.
Yeah. Right, we're coming up to the end here. So I think there's more questions, but we'll probably have to take those afterwards. I just wanted to finish one question for you all, kind of big picture. When you look ahead, 5-10 years, what do you get most excited about, thinking about the future in this industry, and how do you think about that sort of taking shape? Maybe Parth, do you want to start us off?
Yeah, sure. Look, I get excited about, I tell my family this all the time, that generations after me will just take for granted that they have connectivity everywhere they go. They'll ask me as if I'm some prehistoric animal that, hey, you didn't have connectivity over the ocean? What era did you live in? I think that's really exciting to me. The other thing that's exciting to me is you can test this today. If you have an iPhone 14 or 15 or Motorola device or any of the wearables that one of our partners sells, go outside, test it out. It's real. It's happening right now.
James?
Yeah, I was with my grandchildren this past weekend, and I think about them. My grandson he's 3, and he calls me on video all the time. I can be sailing in the middle of the Chesapeake Bay, and we're on a video call, and I'm on a boat, and it's cool because Grandpa's on a boat. I think if the rest of the world has the ability to connect like that with their families, I think that's a very, very important thing, and that's kind of how I see the future, is this ability to communicate in a very high quality way around the world is going to continue to increase.
Last word to you, Brian.
Yeah, I personally, I kind of mentioned it before, but my yearly trips to Alaska fishing in the middle of the ocean, it's going to make a big difference for me moving forward. Also with my kids, being able to make sure that, kids and grandkids, they have connectivity all the time, makes the world a safer place. And at work, for us, we do RF test equipment, so the more connections to whatever it is, be it satellites, LEO, MEO, GEO, UAVs, the stratoplanes, it's really exciting. All these different frequencies from 400 megahertz to 100 gigahertz eventually. It's really great. So yeah, exciting times ahead.
We can all agree on that. Well, I think that brings us to a close, guys. So thank you very much for being on this panel and sharing your thoughts on what is a really fantastic discussion and set of growth in the industry. So we are going to close the summit as well. What I would say, if we go to the last, goes off. We'll go back to it. We are publishing a report this week as part of our Radar series. You can find that, thank you, Abby, at gsmaintelligence.com. It is free to download. You don't need to pay. Please do these are quite well read, and it actually has more in-depth analysis on a lot of the topics we were talking about today. So please feel free to look at that. And do stay in touch. We're getting inundated, frankly, with questions on this topic every week. So we know that means questions are around change and what that means. And hopefully we've gotten at least scratched the surface today as to sort of how to think about the future. So please join me in thanking our panel here, and thank you guys for coming out. Thanks very much.